Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hi, in the given problem, there is a coil in the form of a semicircle, which is having two semicircular parts. In the first case, both the semicircular parts are coplanar here, as shown in the figure. Now, the smaller semicircular part is rotated about the diameter like this, and the orientation of this coil becomes like this. The bigger semicircular part remains same as here, but the smaller semicircular part becomes vertical like this. Here, the radius of small semicircular part is given as 0.20 meter. The magnetic field in which this semicircular part is rotating is given as 0.35 Tesla. The resistance of whole of this coil is given as 0.025 ohm, and the angular speed with which it is rotating has been given as 1.5 radian per second. Now, initially, whole of the magnetic flux was linked with the small semicircular part. So we can say phi 1 is equal to B into A, as the number of turns is just 1. So the flux will be given by just the product of magnetic field with the area of this semicircular part, the smaller semicircular part. And finally, as this small semicircular part becomes parallel to these magnetic field lines, hence we can say the net flux linked through this semicircular coil now becomes 0. Now, as the angular speed is given as omega, having a value of 1.5 radian per second, so in rotating from position A to position B, the angular displacement is just pi by 2. So we can find the time in which this coil has rotated from position A to position B, as time is equal to distance, means angular distance, divided by angular speed, or we can say angular frequency. So this angular distance is pi by 2 and angular speed omega. So finally, using Lenz's law, using Faraday's laws of electromagnetic induction, we can say the EMF induced, the average EMF induced is given as minus d phi by dt, or we can say this is minus phi 2 minus phi 1 divided by time. So this is minus 0 minus b into a divided by pi by 2 omega, or finally we can say this is b into a into twice of omega divided by pi. This is the EMF induced, and for area we can use half of the square of a circle, means pi r square by 2. So this is pi r square by 2 multiplied by 2 omega divided by pi. So cancelling these similar terms, finally the expression for EMF induced, average EMF induced, becomes b r square into omega. So finally the expression for current passing through this coil, the average current passing through this coil in this duration of time will come out to be, using Ohm's law, epsilon by R, or we can say this is B R square omega by R. So plugging in all known values, for B, this is 0.35 Tesla. For radius, this is 0.20 meter, having whole square of it. For omega, this is 1.5 radian per second, then finally divided by resistance, which was 0.025 ohm. And finally, the answer for this current comes out to be 0.84 ampere, having a positive sign. And this is the answer for given problem. Thank you.